Hi everyone. So I hope all of you are doing good. Let me know if you can hear me. If audio, video, everything is fine, let me know. And then we will be starting. So now in this session, I will tell you that how to solve ax equal to 0 or ax equal to b. So basically we will be solving some questions related to a system of linear equations. There could be a system of linear equation which is basically ax equal to 0, or there could be a system of linear equation which is ax equal to b. So we will be solving these type of questions, right? So in this lecture, I will make sure that you understand this part very clearly, because this part is most crucial part in this entire linear algebra. Okay. So we will try to make this very, very clear. And then this session, I think, is going to be for at most 2 hours. At most 2 hours. I mean, it is at most that I think, right? Because there is nothing much that I need to tell, because I have built already the basic that is needed for you. And then we will take one more session, which is today only, which will be for eigenvectors and eigenvalue. That session will also be that eigenvector session will also be for I think 1.5 hours to 2 hours. So this is the plan for today, right? I hope everyone is with me. Now, in this session, as I said, I will be solving some questions related to system of linear equations. Before I go further, let me quickly introduce myself. I'm Sachin. I'm co-founder and instructor at Go Classes. I have achieved GATE CAC All India rank 33. All India rank 33. I have done my masters from IISc, so I'm MTech from IISc. And after IISc, I have also worked at Amazon as an applied scientist. So I work at Amazon as applied scientist. Now, why this? This linear algebra is very close to my heart. It is because I have worked in that profile. So I have worked as a machine learning engineer. I have worked as applied scientist. I have worked as research engineer in various companies like Amazon and Xerox Labs. So since I worked there, I know what are the practical application of linear algebra, and how to apply the linear algebra in practical world scenario. So also, although in these lectures we might not be giving the view which is basically related to machine learning. Reason being is that that is not required for gate, and we are very close to gate. So I will keep myself very precise that I will be just talking about the linear algebra from the gate perspective, but I will definitely be telling you if that is needed, that what are the applications of this linear algebra in machine learning, if that is needed here and there. Okay. So let's just get started with our first topic, which is solving system of linear equations. Now, why we are solving system of linear equation? Why do you even need it? Let me just tell you. Any guesses? So my question is that why solving system of linear equation? So what do you think? Like why do you want to solve? Okay, let me just minimize my video. Right. So let me know what are your perspective. Like why do you think that we are solving system of linear equation? Then I will tell you that why we actually need to solve them. Let me see if there is any doubt. Any plan for probability? Yes, we will be covering probability after AIMT. So tomorrow is All India Mock Test 2. After that, we will be covering probability. Preetham is asking graph theory by Deepak sir. Yes, there will be. I think graph theory is already covered. If I'm not wrong, right? So I think graph theory is already covered. If not, then Deepak will definitely be covering it, and then we will be starting with the another topic. Like Deepak will be starting with another topic, which is basically I think most probably I don't know. Like Deepak might be starting with computer architecture, so Deepak will tell that plan that what Deepak is planning to do next. Okay, coming to this part, why do you think we need to solve system of linear equations? Any guesses? I mean, what are the practical applications of this? Let's just spend 2-3 minutes in this. I mean, let's just spend not much time, but maybe 3-4 minutes, so that you get to understand that why we are even solving system of linear equations. So, any idea? Let me know. I mean, you might not be knowing it very practically, but still, like whatever you know, you can just share that with me. Where we need it in our real world application. Can you think of machine learning application related to system of linear equation? That is my basic question actually. So can you think of machine learning application related to system of linear equation? That is my question. Which means if you can you predict the future using the system of linear equation? Okay, so that is my basic question. That can you predict the future? Can you predict the future? Just solving system of linear equations. Let me know what are your thoughts. Whatever coming to your mind, you can just share that with me. Okay. So let me tell you one application. There are many applications. Yes. So Swapnil is saying that to know whether the equation is consistent or not. Okay. Others is saying yes, sir. Regression. I don't know. Graph regression. Okay. Let me just share one of the thing that yes, you can actually predict the future using a system of linear equation. How? Let me just tell you one of the very popular machine learning application which is called linear regression. And I mean system of linear equation is not just limited to that particular application, but it is the best interest to show you that you can actually develop a linear regression, which is a model in machine learning, just using a system of linear equation. How? Let me just tell you. Suppose you have couple of houses. I mean, you live in an area, right? So there in your locality there are couple of houses. There are many houses that are built, right? Maybe you will say that this is one house one, and then I mean not just in your locality, you can say I mean in your city or whatever, like you have the data for the city, because locality is basically we having very less data, right? In your city, let's suppose there are many houses. Then you will say that okay, this is the house one, and then this is the data for the house one. Data means that this house was let's suppose built in some year, like that, right? I mean there will be some couple of parameters for this house. Maybe what are the square feet of this house, right? What are the square feet? Let's suppose this is the one parameter. Similarly, there is another house which is house 2, and then there is another parameter which is let's suppose number of washrooms, right? There is another parameter. Let's suppose this house is how much bhk. I mean, let's suppose it is flat, or I mean it is a villa or flat, or like that also you can classify. Or maybe you can say that what is the what, or like how many are the, maybe you can say living rooms, or maybe you can say that how many are the bedrooms, or like that. Or maybe you can say the area of dining room. So basically there could be many parameters that you can have associated with the house, right? So let me just say that suppose that there are some couple of houses, and based on that parameters you have some values. So let's just have one table. Okay, let me just put one table. And so let me just put this table. This table is nothing but just showing that okay, there are a couple of houses which have certain parameters, and then they are having certain price. So it is just showing you that there are certain houses which are having certain price. So this is the only thing the table is showing, right? So see here, this house one is having one of the parameter which is square feet. This is 1200 square feet, and then so on, right? And then finally, let's suppose you are saying that okay, there is some house of this, there is some price of this house. So for example, house one is of price maybe 25 lakhs or something, right? So this is the data of your house. I mean, this is the data of the houses that you have in your city. Is this good enough to everyone? Let me know, right? So this is the data that you have. Now let's suppose that you have this data with you. Now what you will do, you will say that to someone, let's suppose you do not know machine learning at that point in time, and then someone comes to you, and then someone says that see, you have a very good data. I mean good data means you have the knowledge, right? I mean in human terms it is called knowledge, and in machine terms it is called data. So suppose you have some data, or you have some knowledge, which means you are very good knowledgeable person in terms of the houses, because there are many houses for the data you have. Like you know that okay, if the house is of this much square feet, house is having these many washrooms, and so on. There are many parameters. The house was built in 2000 year. That house is how much old. There are many parameters. Based on that, you decide that okay, this has been sold. Okay, this is past data. This is the past data, which means that the house has been sold for 25 lakhs, has been sold for 30 lakhs, 30 lakhs, has been sold for 35 lakhs, something like that, right? Now, this is, let's suppose, thousands of houses you have. So these are the thousands of houses data you have, house thousand, and then this is the data that you have, which means you are really a knowledgeable person, isn't it? So you are very knowledgeable person. Now, let's suppose there is some person who is very new and who wants to invest in your locality. Then he will say that okay, I want to purchase some house in your locality. Then can you just help me with something? Which is that, can you just suggest me that the house that I'm looking for is basically, let's suppose that someone says that I have a deal, which means that I want to, let's suppose someone wants to sell his house, and he says that okay, see, this is my house. Okay, this is my house. For that, the data you do not have, so obviously because that has not been sold in past, because you just have the past data. Okay, so that's why you do not have the data for that house. But he's saying that see, my house is having this parameter. Maybe he's saying that the number of square feet are 900, and let's suppose he's saying the number of square feet are 900, number of washrooms are anything, let's suppose it is 1, it is 2, then suppose it is 1, then let's suppose area is 200 square feet or whatever, right? I mean, for the dining area, it has been built in 1990. Let's suppose he tell you many of the parameters. So, and he just ask you this, which means what he is saying that see, you are really a knowledgeable person. This is your knowledge, which is called data in terms of machine learning, or in terms of machine, it is called data, right? This is your knowledge, or this is your data. And then some new person is coming to you, a new person is saying that see, I want to sell my house, can you just help me? Then you will ask, okay, tell me the parameters. So based on my knowledge, I will just think that okay, it is 900. 900, then maybe देखो 1200 स्क्वायर फीट था, और एरिया इतना था, तो 25 लाख में बिका, लेकिन 1300 था, और एरिया तो 2010 में बिल्ड था, तो ज़्यादा में बिक गया, 35 लाख में बिक गया। आपको पुराना भी है, छोटा है, आई थिंक मैं पूरा कैलकुलेशन करता हूँ, एंड मे बी आई थिंक आई एम कमिंग अप विद द नंबर विच इज 20 lakhs, लेट्स सपोज। ओके, आई मीन how he is telling the 20 lakhs based on the knowledge that he has, right? Isn't it? Let me know if that is clear to everyone. So based on the knowledge, he will just tell that okay, the price is 20 lakhs. So similarly, using the machines, you can do the same thing. How? You will be just solving system of linear equation. You will be saying that okay, let's suppose this column is x1, this column is x2, this column is x3, this column is x4. Then you will be making one equation, which will be how you will make one equation. So based on the data that you have, you will make one equation which will look something like this. You will say that this is the data that you are having. Now my equation is 1200 x1 plus 2x2. Okay, 1200 x1 plus 2x2 plus 3x3 and so on, plus 2000 xn, something like this, right? So 2000 xn. Then you will say okay, this is 25. Similarly, there will be next equation, which is 1100 x1 plus and so on, and then 1990 xn equal to 30. Similarly, there are n equations, and from here you will be solving the system of linear equation, right? Like you do not have this with you, which is the new entry you do not have. You will be having it later. So suppose these are the n houses that you have, and then you say that okay, I have the n houses, I will do what? I will find out my parameters. So it is called parameter finding. So once you solve the system linear equation, you will be having x1, x2 till xn. You will know all the values, right? You know all the values, that what is x1, what is x2, what is xn. So since you know all the values, then what you will do? Now you know all the values. Now if someone is coming, someone new is coming to you, then what you will say? That okay, tell me the parameters. See, I know x1, x2, x3, I know everything, right? So if some new person is coming to you, then you will say that okay, let me do one thing. See, I just did one thing. I have calculated x1 to xn from here. I have calculated x1, x2 to xn from here. Then I will do what? If you are coming to me with this new data, I will apply my parameters to you, which means I will say I will give 900 into x1 importance to this, 1 into x2 importance to this, 2 into x3 importance to this, and so on. And similarly 90 into x10 importance to this. Then I will actually calculate it, right? Because I know x1, x2, xn. I know all of this number. So what I will do, based on the previous data, I will find out my parameters, which are x1, x1 to xn, then I will say that okay, someone new is coming to me, no worries. Then using my parameters, which is basically the information, which is the crux, right? That are the parameters basically which you have summarized or you have calculated from your data, and this is very very powerful parameters, because this is not just you have calculated randomly based on the data you have calculated it, right? You have solved the system of linear equations, you have got this x1 to xn, then you are saying if someone new is coming, then let me just fit it, right? Let me just fit it and let me calculate it. Isn't it so nice? Because as a human you are tend to do mistake, because whenever you are thinking like okay ये 900 है तो ठीक है, चलो इतना छोटा है, इसको कितनी इंपॉर्टेंस देनी है, दिस इज द इंपॉर्टेंस दैट इट इज टेलिंग कि इसको कितनी इंपॉर्टेंस देनी है, इसको कितनी इंपॉर्टेंस देनी है, एंड सो ऑन, राइट? तो बेसिकली यूजिंग योर पास्ट डेटा यू कैन टेल द फ्यूचर कि फ्यूचर में ये इतने का बिकेगा, या फिर अभी इसकी करंट रेट ये है. Isn't it? Let me know if that is clear to everyone. Okay. So I hope that is making sense, right? Cool. So that's the application of system of linear equation, and it is just one application, but there are many other in machine learning, and that is basically like linear regression, in fact logistic regression, PCA, and there are many others, okay, which are based on system of linear equations. So that's why this topic is extremely important, not just for the gate but also for the interviews, and not just for the interview, in future also, like if you do masters in machine learning, then also it is very very important. So anyway, let's just focus on the gate only, and let's just continue with our discussion limiting to the gate. So I will not talk about the machine learning, I will just limit myself to the gate. But before that, let's just quickly recap what we have studied. Okay. We have studied what is linearly dependent, what is linearly independent. So I hope that is clear to everyone, that what is linearly dependent, independent. So I will say that if we want to be linearly dependent, if and only if there is at least one vector that can be written in the form of others, at least one vector you should be having. Need not necessary that all the vectors, but you should be having at least one vector. Okay, I hope that's clear. Let me know if that is fine. So someone is asking, is it important that a summation of those xi is one? No, it is not important, first of all, and you should not be worrying about it, because we are not concerned about the machine learning application. I just told you for the sake of little interest. Okay. So given this equation, I will be asking, is Ci 0? Is there exists one Ci? Then based on that, I will decide whether it is linearly dependent or independent. Agar if there exists a Ci which is non-zero, then I will say it is linearly dependent. Otherwise, I will say it is not. It is linearly independent, right? So I'm interested in non-zero Ci. Then we have said that what is the filling the space, which means if there are a couple of vectors, then I will say that okay, these vectors will fill the space. Then if there are linearly independent vectors and there are n vectors in Rn, then they will definitely fill the space. For example, if you are having R3 and then there are 3 linearly independent vectors, then they will fill the space, right? Okay. And then similarly, if I just ask you that how many maximum linearly independent vectors could be there in Rn, then it could be n. Maximum there could be n, right? Similarly, for R3, maximum you can have 3 linearly independent vectors. These are just 3 linearly independent vectors which are just convenient to me. It is not, nothing is special about these vectors. It is just convenient as a human, right? Okay. So as I written here, these are the many sets in R3 which are linearly independent, but these are just convenient vectors to me. Okay. Otherwise, you can have obviously many sets in R3 which are linearly independent. Cool. Now we have seen that how to multiply a matrix and vector, which is a eureka moment for us, I can say, right? I mean, that is something that is connecting all the dots of linear algebra. Once you know that how to multiply a matrix and a vector, then you know many of the things of linear algebra. Let me know if that part is clear to you or not. Like how to multiply, at least that is clear. That AX is always a linear combination of columns of A. Then it depends on B. Is B a linear combination of columns of A? Then AX equal to B have the solution. If it is not a linear combination of columns of A, then it does not have the solution, right? Okay. So I hope that was the clear, because that is the most important part that we have seen in linear algebra. Okay. Now then we have said, like we have proved one thing, that if V can be represented, let me just maybe just go over that, or maybe you can also recall, right? So just a second, let me just go over that. So we have studied one thing, which is basically if V can be represented as a linear combination of linearly independent vectors, then there is just one way, right? Yeah. So I just found it. Let me just write it there also. Do you remember this particular concept, that if you are representing as a linear combination of other vectors, then it is good. But if the other vectors are linearly independent, then there is just one way. If they're linearly dependent, then there are always infinite ways, right? So for that, there has been we have solved one gate PYQ, right? One gate PYQ just based on this concept. Cool. I hope you remember this concept, because this concept are very important. Okay. We have proved it, and uh, then we are talking about, let me just go here, we have solved this. Yeah, unique solution, then linearly independent. Okay, these both are same. Yeah, this is, we have talked about matrix into vector. And then today we are just going to study system of linear equations. Let me quickly start with the system of linear equation, then you will get to understand some more things in this, right? Now, suppose you have these three equations, and if you want to solve them, then what you will be doing, you can just eliminate. You can just eliminate other this x from here, and then xy from here, and then finally you get the answer. So that's what we are going to do in system of linear equation also. We are just going to do in the matrix format instead of just doing in the linear. Just equation format. We are just going to have a systematic way, which is called Gaussian elimination, right? So we want to convert this from this. So this is our goal, and this is called Euclidean form, and the process is called Gaussian elimination. So anyway, in the matrix representation, we are going to do the same thing. That's called solving a system of linear equation. So I hope you know what is Euclidean form. Euclidean form is basically that you are having a pivot. You are having a pivot here, and then in below this pivot everything is zero. Then the first number should be the non-zero, which is the pivot. First non-zero is always a pivot. So basically these are the three pivots here. This column does not have any pivot, so this is called free column. If it does not have any pivot, it is called free column. This is the pivot, this is the pivot, and this is the pivot. So these two are in the equivalent form, right? Cool. Similarly, if I just ask you that are these two in equivalent form, then answer is no. Reason being is that the zero rows, okay, should be at the end in the equivalent form. So if they are in the between, then it is not in the equivalent form. So for simplicity, what we have, if you can make the stairs, just put the pivot element. Okay, just mark the first non-zero. This is the first non-zero of this row. First non-zero. This is the first non-zero. Okay, first non-zero. These are the first non-zero of the row. Non-zero of the row. Then see if you can make the stairs. Make stairs. Then these are in the equivalent form. Now tell me, if this is the first non-zero and this is the first non-zero, can you make the stairs without, obviously, you cannot cross the zero zero. So you start from here, and then in this column you go below, you go below in this row, and you are not finding the pivot, right? So you cannot make the stair, and then you are saying like this. So this is not a stair. You have to form some stairs like this. Then only it will be an equivalent form. Similarly, if you go here, and then that's good that you are going here, then it should be the pivot. 3 should be the pivot here, but the pivot is 1. This is having the non-zero, so that's why it is not also in the equivalent form, right? Because you are not able to form the from the stairs. So you should be forming the stairs. For example, let me just ask you whether this is in the equivalent form or not. Tell me. I'm not telling you that what are these numbers, but suppose these are the non-zeros. Okay, the square boxes are non-zero. Then tell me, is this in the equivalent form? Okay, so this is an equivalent form, right? If square boxes are non-zero, then this is an equivalent form. Now, tell me which matrices are in equivalent form. Okay, these are the 4 matrices which are given to you, and then you should be telling me that which matrices are in equivalent form. Let's suppose this is A, B, C, D. See here, can you form the stairs? Then answer is yes, you can form the stairs. So this is in the equivalent form, right? This is in the equivalent form. A is in the equivalent form. Okay, B is not in equivalent form because you have to cross this row, and there is no way to cross this row. You can cross only using the pivot, right? 0 0 cannot be in the between. So B is not in the equivalent form. B is not in the equivalent form. A is in the equivalent form. What about C? C seems to be in the equivalent form, but then you just have to go directly, right? So that's why C is not in the equivalent form, because you have to make the stairs, and every step length should be 1. You should be going step by step. It should not be a decrease like this, right? So that's why it is not in the equivalent form, because your stairs should be like this. These kind of structure should be a stair. So that's why this is not in the equivalent form. What about this? You start from here. You start from here. What do you think? Is this in the equivalent form? What about D? Yes, D is in the equivalent form, right? So A and D are the equivalent form. I hope you understood this. That was an easy question, but for your sake of practice, I just put it there. Now let's just move further. Now what they are saying, that convert the given matrix in the equivalent form. Then they are saying another way of asking the same question is that apply the Gaussian animation. So the process is called Gaussian animation. Now how to do it? What you need to do? You need to apply the row elementary row transformation rule. I hope you know it because I'm just running the marathon, which means like I'm just assuming that you know this. I mean very basic stuff. If there is any conceptual thing, I will definitely be covering it. So now what we are going to do? We are just going to apply the row reductions, and then finally you get you get some matrix which is in the equivalent form. Let me know if you want me to explain what is the row reduction and all, or you already know this. Can I assume that you know what is the row reduction? Let me know. Otherwise, I can also quickly go through the row reductions. It will unnecessarily take some time, but yeah, we can do it. Okay, assuming that you know it, let me move further. Right? Cool. So let's just move further. So basically, what we are doing, we are applying the row reduction from this matrix to this matrix. I'm saying R2 gives R2 minus R1. So just take care of one thing. I mean, what you need to do, you basically need to have this. If this is R2, then you basically need to have R2 definitely on this right hand side. Okay, that is for sure. And then see what you can do. If this is Ri or R2, then on the right hand side you must be having R2, but just start with R2 only. I mean, I don't want to confuse you, but the thing is that you can also start with one by two R2 or something like this, but it will be a little problematic to you. Let me just tell you that why. I mean, why sometimes it will be problematic, because you need to remember two things. See, what is this R1 R2? These are the rows, right? These are the equations that you have. So what you did, you have written the equation. You have written your equation in this matrix format. And let's suppose this is the augmented matrix, which is, let's suppose this is A, and then this is B, right? I hope you are getting what I'm trying to say. So suppose that you have some set of matrix this, right? Then what you will do? You will be writing a corresponding AX. I mean the matrix coefficient matrix or the augmented matrix for this particular set of equations. How you will be writing? You will be saying that okay, this is 2 4 minus 2, and then you will say that okay, this is bar, this is 2, then this is 4 9 minus 3, this is 8, then this is minus 2 minus 3 7 and 10. So that's how you will be writing it. Now tell me, what does this mean of saying that R2 gives 2, let's suppose R2 gives R2 plus R3. What does this mean of saying? In the equation format, it means of saying that instead of R2, you are going to write R2 plus R3. Basically, you will replace this equation completely with the with R2 plus R3, which means you will add these two and you will replace this completely, which is definitely fine. Reason being is that you can again produce the same R2. I mean, you are not losing any information. You can again produce the same R2 if you want to, by the subtraction, right? So that's why you are allowed to remove it by the replacing sum of two. Now tell me, are you allowed to remove this by the sum of these two? Which means, can you do something like this? R2 gives R2, R2 gives R1 plus R3. Can you do something like this? Let me know. Let me know if this is the valid transformation that you can make. Okay. So this is not a valid transformation. Why? They are saying that you just remove this. I mean, जो given information है, you are just removing it, which is not at all valid, right? So that's why you must be having R2 on the right hand side. One thing is for clear to all of us, that if we want to replace R2, then we have to use R2. We cannot replace R2 without using R2, right? So that's why I will say that if you are starting with R2, then you have to have R2 on the right hand side. This is the for sure thing. Now let me tell you one more thing, that can you do something like this? Let's suppose you have this, okay? You have this is the set of equation, and which means that you are writing 2 4 minus 2, and then there will be 4 9 minus 3 minus 2 minus 3 7, and then this column will be 2 8 10, right? So suppose you write something like this, and then if I just ask you, see, one thing is clear, that R2 gives R2 minus R3, R2 gives R1 plus R3. These kind of things are not allowed, right? Not allowed, because it doesn't make any sense. You are removing the R2 completely, doesn't make any sense, right? Okay. Now tell me if this is allowed. If this is allowed, can you write something like this? Can you write R2 gives 2R2, 2R2 plus R3, or maybe just 2R2? Let me know if this is allowed. The answer is that yes, it is allowed. Like you can definitely multiply 2 here, right? You are saying that replace this the second equation in the equation format, replace the second equation by 2 into R2. You can definitely do it. No one is stopping you. But I will say that you don't do it. I will tell you the reason. Okay, don't worry. See, you can definitely do it, and there is no problem at all. But if you remember it, then you have to remember one more thing, which is in case of determinant. So I will tell you that what you need to remember. So anyway, like you can definitely do this R2 gives to R2. There is no issue at all. Okay. Now tell me, can you do? This is also allowed. Now tell me, can you do R2 gives to R2 plus R3 here? Yes, you can definitely do, right? I mean, you are just multiplying by 2 here, and then you can replace, you can add these two. So that's perfectly fine. And then final result you are replacing with this R2. So that's perfectly allowed. There is no problem. As long as you are using the R2, you can do whatever you want. Okay. As long as on the right hand side R2 is there. Okay. If you are starting with the R2, if this is Ri, as long as on the right hand side Ri is there, you can do whatever you want, right? So as long as Ri is there, do what you want, whatever you do. Okay. But I will suggest you to not use a coefficient with this. So basically, what I'm suggesting you, basically, if you are having R2, then just do R2 plus KRI or whatever, right? I mean, plus minus whatever you want to use. But don't use any coefficient here, which means don't use this K1, K2, or don't use any coefficient here. Reason being is that you can do it, there is no problem. But you have to remember one more thing. The thing is that in the determinant, okay, when you are doing the determinant, see, currently you need to understand that what we are doing. Currently we are solving system of linear equation. In this everything is allowed. I mean, as long as you have R2 on the right hand side, you can do whatever you want to do, right? But in the determinant, you cannot do this kind of operations. R2 gives to R2, you cannot do in determinant. Not allowed in determinant, because it will actually multiply the value of the determinant by 2. Determinant will not be same, right? You can do it, but the final value will be the 2 into the determinant. So basically generally we don't do it in the determinant, not in determinant, right? So in determinant, we don't multiply with some coefficient. So that's why I'm just saying that don't multiply with this coefficient, because this is applicable to ax equal to b and determinant also. But in determinant, this k1 is not allowed. Which means, just to summarize what I'm saying, that if you are solving ax equal to b, then you can do ri gives k ri k1 ri. Okay, let me k1 ri. You can do this k1 ri plus K2 Ri, K2 Rj. This is definitely allowed in case of Ax equal to. In case of Ax equal to B, as long as you have Ri, you can multiply with this. You can multiply with K2 or whatever you want to do. You can definitely. Now let's go to the determinant portion. Okay. Suppose you are solving the determinant. You are solving the determinant for A, and then you need to apply the elementary row transformation. In that case, this is not allowed. This is not allowed if you are solving for determinant. I mean, the determinant will not be same. You can do it. There is no problem. I mean, I hope you understood my point. You can do it. Then the final determinant will be the k times of the determinant that you already have, right? Because you have already multiplied by k. K times or 1 by k, 1 by k1 times you need to think. Because see, you are multiplying this matrix that you are getting B determinant. After that this transformation you will be getting, let's suppose, B determinant, that is already k times of A, right? I mean, you multiply the k in here in the determinant of A, then you got this B. So anyway, that's why this is not allowed. But you can definitely do this thing. Basically in the determinant, don't do this. So that's why this is allowed. This is allowed in both the places, right? This is allowed in both the places. That's why I'm just saying that it is better if you remember it this only. Okay, let me know if that is clear to everyone. So basically this thing is allowed in both the places. In x equal to b, you can multiply by k1, and you cannot multiply by k1. Both are fine. But in mod A, in determinant A, you cannot multiply by the k1. So that's the thing that you need to remember. So let's just do one thing. Let's just remember the common thing, which means let's just remember this rule, that you are not able to, you are not allowed to multiply with k1 in case of Ri. Okay. So whenever you want to do some elementary row transformation, R2 gives first write R2, then plus whatever you want to write. That's the rule that we are going to follow. Cool. So hope you understand this. Let me know if there is any doubt in this. So what we are going to do, if we are going to solve either for ax equal to b or determinant of a, we are going to follow this particular rule. If you can remember, I mean, if you want, you can definitely multiply. There's not an issue, but I mean, this is my just suggestion. I made made everything clear. Now it is up to you. If you can remember that, okay, in ax equal to b, because it is fair, in ax equal to b you can multiply two LHS and RHS, because there is a LHS and RHS concept. But in determinant of a, there is no LHS RHS concept, right? So in determinant of a, you cannot do it. So if there's a LHS RHS concept, you can multiply to both sides. No one is stopping you, right? So that's the differentiation. Okay, cool. I hope I made it clear. So you are comfortable with this now, right? So what we are going to do, we are going to apply some transformation. Let's suppose this is the transformation that we apply. Then we get this. Then we are going to apply some more transformation. Then we get this. Then finally we have this matrix, which is basically in the echelon form. Okay, so that's how we are going to convert in the echelon form. Now we are going to drive some more interesting points from here. Okay. So Saloni is asking, good afternoon, sir. Where is the solution of AIMT test one? AIMT test one solutions are available in the test format. I mean text format. But those, if you have any doubt there, then you can definitely comment on the GATEOverflow. Then you can ask us that whatever the doubt you are having. Okay. Some of the questions are basically available in the video format also. Cool. Let me know if that is clear. Now here, if you see that this column, there are different columns. How many columns are there? 4 columns. If you see, this column is having a pivot, this column is having a pivot, but this column and this column, there are 2 columns which are not having the pivot. Those are called free columns. Okay, so these are the 2 columns which are not having the pivot. So this is having a pivot, that's why it is called pivot column. This is also having a pivot, that's why it is called pivot column. This is not having a pivot, that's why it is called free column. Now, if it is a free column, then you can represent this as a linear combination of the pivot columns, which means this 1 minus 2 can be represented as a linear combination of these pivot columns. Now, the coefficients we need to calculate, but you can definitely represent it. Okay, there must be some coefficient that we need to calculate, but that's for sure that you can definitely represent it. Because anyway, these are the 2 linearly independent columns. Then you have this column, and like, I mean, although everything is in R3, but it seems like that, I mean, the third dimension does not matter to us, right? Sorry, this is minus 2. Sorry, this is, yeah, this is 1 0 0. This is 3 minus. Okay. So you can definitely represent free columns as a linear combination of pivot columns, but the coefficient you need to find out. There is a way to find out the coefficient, but let's not do it now because that's not required. Cool. So here you got the coefficient which is minus 2 and 1, and there is a way to actually find out the coefficient which is called row reduced equivalent form. Row reduced equivalent form. Okay. This is just a row equivalent form, but there is a row reduced equivalent form which directly give you the coefficient also, which is very nice form. And you can do it in the row reduced equivalent form if you know. Otherwise, that's not required for the time being. Now let's just move further. I hope these things are clear. Now let's just move to very powerful definition, which is called rank. Before that, let me know if there is any doubt till this point. Hope everything is clear. I mean, I just told you that how to convert that to a row equivalent form, right? So there are operations that you can apply using which you can convert to the row equivalent form. Now let's just move to rank. Rank is defined as number of linearly independent rows which are same as number of linearly independent columns, which are basically number of the pivot elements in the echelon form, which are non-zero rows in the echelon form. So basically, either you count the pivot elements, which are actually, let's suppose this is pivot, this is pivot, this is pivot, and let's suppose these are the 0 rows. Okay, everything is 0 here. Everything is 0. So number of non-zero rows, you say number of non-zero rows, or you say number of the pivot columns, or you say number of linearly independent rows, number of linearly independent columns. Basically, these two are very important. This is called as rank. This is a single number which tells so much of the things about the matrix. So if someone asks me that what is a single number that can give you the most information about the matrix, then I will say it is rank. Okay, a single number that can capture most informations about matrix. I will vote for the rank base. Cool. Let's just move further. The matrix dimension could be anything. Maybe it is 3000 into 5000. Matrix dimension, let's suppose this much big. It's still a single number. Which is rank. which is telling so much of the things about this matrix, which means it is telling that how many linearly independent rows are there, how many linearly independent columns are there, and so on. Okay. So suppose if I ask you to find out this rank of this matrix, then what you will do? You will say that okay, let's just count. I mean, since it is already in the row equivalent form, then you will say that see, it is already in the row equivalent form. Let's just count the number of pivot elements. This is 1, 2, 3, 4. So that's why rank is 4. Right? Very easy question. Now let's solve this question, which has been asking GATE 1994. What they are saying, the rank of this matrix will be. Now what you need to do, you need to convert that to a row echelon form. That's the best idea. Okay, convert that to a row echelon form. So for that, if you notice that 0 is here, so let's just exchange two of the rows. Any two of the rows you can exchange so that you have the non-zero here. Okay, so I'm going to exchange this last and first. So once you exchange, which means that you apply, it is called basically the row exchange elementary operation, which is R3 and R1 you are exchanging. Anyway, like that's very obvious operation that you can do. So it is basically going to have 3 1 1 and then 9 3 5 and then 0 0 minus 3. Can anyone tell me why I have not exchanged this with 2? Why with this 3? Because I want zeros at the end. So why not exchange with the last row, right? Because anyway I want zeros at the end. So okay, now you can apply. Now you can apply the rule where you will say that let's just replace this R2 by R2 minus 3R1, right? So you are replacing R2. That's why R1 is same. This is 0. R2 minus 3R1, which means 3. Okay, 3 minus 3, which is again 0. 5 minus 3, which is 2. And then you are having 0 0 minus 3. Let me know if that is in the equivalent form. Currently, see, this is the pivot. This is the pivot, but below the pivot it should be 0. So currently it's not in the equivalent form. You can definitely convert to the equivalent form. So now you have the matrix, which is 3 1 1 0 0 2, right? 3 1 1 0 0 2 and then 0 0 minus 3. Now let's just convert. See, this is the pivot element. Everything below this is 0, right? Everything below this is 0. This is the pivot element. Everything below this is not 0. So let's just convert this minus 3 to 0. How you are going to do it? Can you apply some transformation? Definitely. What is that transformation? You can replace this R3 by whatever is the multiplicative it is, right? Maybe you can replace it with this is minus 3. That should be multiplied to get it at 2. I think 2 by 3 minus 2 by 3, right? So R3 plus 2 by 3 R2. Anyway, like you can find out the coefficient to which you need to multiply so that you get 0 here. So you can convert it to 0, not an issue, right? Not an issue. So basically you can convert this to 0. So that's why the rank is 2. So very, very easy question. Okay. So rank is 2. Now let's just move further. Now let's just see this question. What they are saying, that a matrix A can be in row reduced form in the a matrix A can be row reduced to the following equivalent form. So they are saying that A has been row reduced to this following equivalent form. So you apply some transformation. Finally, you got this as a row reduced form, which means you are saying that this is a pivot element, this is a pivot element, this is a pivot element. Either all of this are 0, or if A is a pivot element, then also it is okay. I mean, all of this also could be the 0 because they are just saying ABC. Now they are saying depending on the values of constant ABC, the rank of A could be. This is MSQ question. So what could be the rank of A? Tell me. If A, B, C all are zeros, then I think it is very easy. The rank will be 2, right? Let me just help you with one of the condition. If A equal to B equal to C equal to 0, then rank of A is equal to 2. Definitely, right? So must be 2, I cannot say, but can be 2, right? Can be 2. Can it be 3? If you want it to be 3, then A should be non-zero. A should be non-zero and C should be 0, right? A should be non-zero and C should be 0. So that it is 3. Rank of A would be 3. And if A and B both are non-zeros, right? If A and C, if A and C both are non-zeros, then rank of A, right? So that's why it could be 2, 3 or 4. Can it be 5? No, because these are the only 4 rows. How can it be 5? So that's why the answer is D. Okay, so earlier the coefficient was 3 by 2. No, I think, yeah, sorry, it is 3 by 2. I thought I need to multiply here. Okay, so it is 3 by 2 here. If you're writing it here, it is 3 by 2. Yeah, thank you for correcting me. Okay, cool. Let's just move further. Now, what we are going to do, we are going to solve the system of linear equation. For that, we will be having either Ax equal to 0 or Ax equal to B. Now, what we need to do, we need to understand. See, anyone can solve the system linear equation by applying the row transformation and all. But we will go just one step beyond of this. We will limit ourselves to the gate, and then just by looking at more, we will understand few more things about the system linear equation. For example, if this is the augmented matrix that you have, this is the matrix, this is a set of linear equations that you have. You convert that to an augmented matrix, which is very easy. Then they are saying that to find the number of solutions, we need to perform the augmented elimination of the on the augmented matrix. So let's just do it, and let's just have very first example in place. Now this is the very first time we are actually going to solve some system linear equation. So let me know if you are ready. So we are starting with ax equal to 0, right? So let's just start with ax equal to 0, solving ax equal to 0, and then we will be solving ax equal to b, and then you will see many interesting thing, and then we will be also solving the gate p by q, which can be solved just by very intuition if you are having that how to solve ax equal to 0. So let's just start with this. This is the very first time we are going to solve it, right? Now I just told you the definition of rank and all, and then what is the Gaussian elimination, and these things are done, right? So rank definition is done, Gaussian elimination is done. So I think now we are very much set to start ax equal to 0. And then once we start x equal to 0, then we will quickly be jumping to x equal to b, because both are almost same, right? And then we will be just solving many interesting questions, so that you get to understand these concepts a little more. So what you need to do to start with, you just have to convert that to augmented matrix, right? That's very first step. So let's suppose this is the set of matrices, this is the set of equations you have, then you will be converting that to augmented matrices. Now here, every column, just notice here that every column is basically corresponding to one variable, which is x, y, z, and right hand side is basically written here after this bar. Okay, this is the notion that we will be using. Now what you need to do, you need to apply the row transformation. Okay, so let me probably just do it. Let me just copy this on the next page, and let me try solving the system of linear equation for this particular three equations. So the very first step is that you are going to convert that to augmented matrix, right? Okay. Now remember that these three are corresponding to the variable which is x, y, z, and this is not corresponding to a variable. This is just a right hand side, right? So maybe you know it, but anyway, let me just put it there. Okay. Now what you are going to do, you are going to apply the row transformation. You will take this one, you will apply the row transformation. You will take this -2, you will apply the row transformation. Do you want to do it, or let me do it maybe? So do you want to try it first? Cool. So let's just do this quickly, right? Now we have this one. So what you need to do, you need to make it 0. You need to make it 0. You can simply do R2 gives R2 minus 3R1. Very easy. Similarly, R3 gives R3 minus 4R2. 4R1. So you will be having this as 1, 1 minus 1, 1, because you are not even disturbing this. And then you are saying that replace this R2 with R2 minus 3R1, which means R2 minus 3R1, which is 0. If you do -2 minus 3, it will be -5. You do 2, you do 1, 1 plus 3, it will be 4. You do 3 minus 3, it will be 0, right? Similarly, you do here, it will be 0, and then it will be R3 minus 4R1. So basically, you subtract 1 minus 4, it will be -3, it is -5, and then this is R3, which is -2 minus 4R1, which is +4, you are getting 2, and then this is R3, which is 9 minus 4, you will be getting 5. So basically you are getting this matrix first, and then you again need to apply the row transformation, and then you need to solve for system linear equation. So this is done. Then let's just apply the row transformation here. Okay, let me know till this part is everything is clear or not. So what you need to do, you again need to apply the row transformation here. You just did this row transformation, these two row transformation. Now one more you need to do, which will be, you need to subtract, like you need to replace this R3 by R3. Maybe just for the simplicity, okay? I mean, that's not required, but just for the simplicity, I'm saying that you can multiply. I mean, you can use this KRI plus K1RI plus K2RJ, maybe, okay? Because this is a set of linear equation, I can definitely do it. But in case of determinant, you have to be very careful. You cannot do it. So maybe I can do it. So I can say you multiply 3 here, you multiply 5 here, and then you subtract to each other, right? So which means you multiply 3 into you multiply 5 into R3 minus 3 into R2, right? Because you multiply 5 here, it will be minus 15. You multiply 3 here, it will be minus 15. And then you subtract each other. These are the same numbers. You subtract each other, you will be getting 0. So finally, you will be having 1, 1 minus 1, 1, 0, minus 5, 4, 0. And then finally, you are having 0, 0. Then these two numbers you have to calculate, which is 5R3. You need to subtract 10, 10 minus 3R2, which is 12, which is minus 2. And then 25 minus minus 0, which is 25, right? So finally you are getting this. Now, is this in the equivalent form? We check. Is this the equivalent form? So yeah, this is the equivalent form, right? So see here, this is the equivalent form, because these are the 3 pivot elements, right? Okay, I hope you understood. So now what we need to do, we need to solve for the linear set of linear equation. So you have this. Now you need to basically write it in the way that you can solve it for the set of linear equation. How? You will say minus 2x3 is equal to 25, and then similarly, once you get this x3, you are going to put it here, minus 5 x2 plus 4 x3 equal to 0, and then x3 value you can put here, and then similarly you can solve for x1. How? See, for x3 value you can put here, you will be getting x2, and then you will say x1 plus x2 minus x3 equal to 1, and then once you get x2 x3, you will be getting x1. So that's how you can solve system of linear equation. Maybe it was a little ugly example. We will be having some nice examples also. Okay. So let's just go and solving system of linear equation, which is ax equal to 0 and x equal to b. So first let's just solve for ax equal to 0, right? And then we will solve for ax equal to b. Now, okay. 1 second. Yeah. So for to solve for x equal to 0, I think this is the same example. Okay, this is a different example. What we need to do to solve for x equal to 0, we will be representing this in the equivalent form, and then we will be, we will be representing in the matrix form. Then we will be converting that to equivalent form. And then finally, we will be finding the values for x1, x2, x3. That's very easy, right? Now here, if you convert that to equivalent form, you are getting 0, 0, 0, 0 everywhere, right? So basically, this last equation is saying that this is 0 equal to 0. Now from here, we were supposed to find out the value of x3, but currently you do not know the value of x3 by just looking this equation. So you say that, see, this x1 and x2 are basically a pivot variable, because here in this column you have the pivot, in this column you have the pivot, but in this column you do not have the pivot. So here it is called x3 is called free variable. Free variable. Okay. Let me know if that is understood. So it is actually very, very important concept, and from here we will be driving one very nice thing. So what you need to do, you will be taking it, you will be representing that into a matrix format, which will be 3, 5, minus 4, and then it is 0. This is minus 3, minus 2, 4, then it is 0. This is 6, 1, minus 8, then this is 0, right? Then you need to convert that to equivalent form, that I have already done for you, which is 3, 5, minus 4. Okay, 3, 5, minus 4. You need to convert it, but I already did, right? So this is 3, 5, minus 4, and then 0, 3, 0, 0, 3, 0, and then this is 0, 0, 0. Okay, let's suppose I did it. Then you will see this is the pivot element, this is the pivot element. So this is x1, this is corresponding to x1, this is corresponding to x2, and this is last column, which is corresponding to x3. Now in the x3 you do not have any pivot element. That's why you will say that x3 is a free variable. Okay, you will say that x3 is a free variable. Why? Because corresponding to x3 you do not have any pivot element. That's why you will say x3 is a free variable. Let me know if that concept is clear to everyone, because that is a very, very important thing that we want to convey here. Now, if it is free variable, then as a step 1, okay, what you need to do to solve this set of linear equation, you set this free variable to be some k. You set this free variable to k, right? So what you need to do, you need to convert as a step 1. Let me write it here. As a step 1, you need to convert to equivalent form. As in step 2, identify free variables and set them to k. Something like this, right? So this is extremely, extremely important step. That is what you need to do as a first step. Now it is very easy to solve for x1, x2, x3. How? Let me just show you. See, if you have this row equivalent form, then what you can do, you take this, you say that okay, x3 is free variable, so that's why x3 equal to x equal to k. This is very important. This is, you can say, the very first thing that you need to do. First thing that you need to do. Then you go on solving. Then you will say okay, 3x2 is equal to 0, and then x2 will be, from here x2 you can find out it is 0. Then 3x1 plus 5x2 minus 4x3 is equal to 0. And then from here you are supposed to find out x1. So put the value of x2, which is 0, put the value of x3, which is k. So x1 will be 4k by 3, 4 by 3k, right? So this is your x1. Let me know if you have understood that how to find x1, x2, x3. See, if this is not a free variable, no problem. If this is a free variable, then this is the first thing that you need to do. Let me know if that is clear to everyone. Okay. So now can you write a vector x, which is basically x1, x2, x3, and how it will look like? It will look like something like this. What is the value of x1? 4 by 3k. What is the value of x2? It is 0. What is the value of x3? It is k. So it will look something like this, right? I hope that is fine to everyone. Now I will say that this is my vector. So basically the final solution that I have got is basically this: x equal to x1, x2, x3, right? Which is equal to 4 by 3k. This is 0. This is k. Let me know if this is fine to everyone, or there is some issue in this, because from here I will drive one concept, and in fact in GATE 2023 they have asked the same question regarding this. Sorry, not 23, in 21. In GATE 2021 they have asked the same question. I will come to that question, but you should be first understanding this. Let me know if that is clear to everyone. Okay, so if that is clear, then let's just move to one interesting concept, which is basically the number of solutions, right? Currently we are just finding out the solution. Now let's just see that how many solutions are present. So ax equal to 0 always have a trivial solution, that is okay. But if you have the free variable here, then you can set this free variable to be anything, because it is free. You can say that okay, this k is 1, then you will be having x as this 4 by 3k 0 1, right? If k is 2, then there will be some other x. You will be having x as 8 by 3k 0 2. So similarly for every value of k there are solutions. So that's why you will say it is a parametric form, and that's why you will say there are infinitely many solutions. Infinitely many solutions, isn't it? See, that's very important, because on the gate they are going to ask, they are going to hit these kind of concepts, that how many solutions are there. So there are infinitely many solutions. Why? Because of the free variable. If there is no free variable, then there are not infinitely many solutions, right? If everyone is fixed, then I mean you cannot set anything to k. If everyone is fixed, this is 4 by 3, this is 0, this is 1. Let's suppose it is fixed to be 1, right? Then you cannot set anything to k. So if there is a free variable, then there is always infinitely many solutions. Hope you understood this. So what we did, we started from this, right? We just converted to a row equivalent form. Then we have said like, okay, if this is a free variable, then why not solve it, right? So solve it using this, right? First set this free variable to k, and then find out the x1, x2 again. Let's see one more example. Then you will be understanding this bit more clearly. Then we will be solving the GATE 2020 21 question, not 23. Okay. So maybe they will ask in GATE 2023. That's why like I'm saying it again and again. But I don't know. Okay. Let's just see. Now now what we are going to do, see here, we are just going to convert it, and this is the first step. So see, this is a slide that I have taken from my classes, that I have taken from the in the course of the Go classes. So that's why these are already written things. I have copied directly the written things, because it just save time in the marathon. Okay, this is the first step to do, to set the free variable to be k, and then you find out x2 and x1. Cool. Then you got this. Then you are saying that okay, this is the thing that you have got, right? So you have got this 4k by 3 0k. You can take this k common if you want to, and then you can write 4 by 3 0 1, right? You can take this k common. It just looks nice, right? If you take this k common, it just look nice. That's all. Nothing fancy in this. You can take this k common. Do you remember that GATE 2001 question? They have exactly given this equation. They have said like how many, I mean, I don't know. I don't remember the question exactly, but yeah, I have the question here. So maybe let's just solve one more question, and then let's just see how it is making any sense. So you have this solution, but this is not just one solution. Remember, number of solutions are infinitely many solutions, because for k equal to 0, you can put any value of the k, even 0, right? K equal to 0, -1, -2, anything, because it is a free variable. Free means it can take any value. For k equal to 0, you will be getting, k equal to 1, you will be getting this, k equal to 2, you will be getting this. That's all, right? And number of solutions are infinite. But there is something called linearly independent solution. That's where the GATE 2021 question has been asked. And I will tell you what does this mean. Okay, number of linearly independent, I will tell you what does this mean. But for now, let's just focus on this number of solutions. Okay, let's just focus on the number of solutions, which are infinitely many solutions. There are just one linear independent solution. I will tell you the little later. Okay, cool. So let's just do one thing. Let's just solve this equation also. Okay, for ax equal to 0. So I mean, this is a, and then if you just augment it, so here I have just augmented it, or maybe I can solve it for you. So let's suppose this is a, and then let's solve for ax equal to 0. Okay, this is the equation that I mean, this is the set of linear equation that I want to solve. So what you will be doing, you first write the augmented matrix. Always write the augmented matrix, either it is x equal to 0 or x equal to b. A is given, yeah, and then you first write the augmented matrix, which is 2 2 1 -1 2 1 1 0 3. This is a, and then just append 0 0. Very easy to write the augmented. Then apply the row transformation. So it is very easy. Here you just have this 2, you need to apply only one time. If you apply this one time, then you need to do like r2 should be replaced by r2, or maybe 2r2 minus r1, or maybe r1 minus 2r2, anything, right? I mean, see, generally I do not write 2 here. Reason being is that for the determinant you cannot do it, otherwise the value of the determinant itself will change. But since I know that it is a LHS RHS concept, right? It is LHS RHS concept, so I can actually do it. So that's why I'm doing it, otherwise I cannot do it anyway. So I hope you understood that I can multiply 2 here, because this is LHS RHS, right? In LHS RHS, why not? So if you just do it, then you will be getting, let me maybe just a little bit shrunken it. If you just do it, then you will be getting a matrix which is looking like this. This is 2 1 minus 2 2, and then this is 0, which is as it is. Then this will be 2r2, which means this is 2r2 minus r1, which is 0. If you do 2 minus 1, this is 1. If you do 0 minus minus 1, this is plus 1. If you do 6 minus 2, which is 4, and then this is 0 minus 0, which is 0, right? You will be getting this. Now, is this in a row echelon form? Let me know. Yes, these are the two pivots that you have, right? These are the two pivots, and this is definitely in the row echelon form. This is the pivot element. This is cool. So what you did, you given this matrix and you wanted to solve x equal to 0. I just converted to that to a equivalent form. Now tell me, what are the free variables and what are the pivot variables here? See, this is having a pivot. Let's suppose this is x. This is having a pivot. This is, or maybe x1 x2, or maybe xyz, anything. So let's suppose this is x1, let's suppose this is x2, let's suppose this is x3, and let's suppose this is x4. And since it is RHS, it is not related to any particular variable. Just remember here, it is not related to any x5, x4 like that. So don't name it x4, x5 like that, okay? Since this is RHS. Now, what you need to do, these are the pivot variables. Now, first step to identify the free variables and set them to k1, k2. So let's suppose that free variables I can easily identify, which is x3 and x4. Why? Because in this x3 and x4 columns, there are no pivots. So that's why x3, x4 are free variables. Right? Let me know if that is clear to everyone. Now x3, x4 are the free variables. Now what you need to do, you need to basically set them. X3 is equal to, you need to say that x3 equal to, let's suppose s, or maybe k1, k2, and x4 is equal to t, right? First step is to set them some values, which is, let's suppose, s and t. Now you can solve for this x1 and x2. How? Let me just show you. See, this was the first step, and then what you need to do, you need to basically solve it. So basically you will say that this 2x1 sorry 2x2 plus x3 plus 4x4 is equal to 0. But since you know that x3 and x4 are s and t, so that's why x2 will be minus of s plus 40, right? Okay, so this is your x2. Now similarly you can find out the x1, which is basically 2x1 plus x2 minus 2x3 plus 2x4 is equal to 0, and from here you can find out your x1, right? Can you quickly tell me what is the x1 that you are getting, because that is important for us, because like we need to just analyze these things more carefully. Okay, so here this all the lecture is about just analyzing this thing. See, the whole crux of the lecture will be basically just analyzing this thing, which I'm going to tell you now. So this is x2, and now from here you can get the x1, which is basically, I mean, you know the x2, and then you need to get the x1, which will be, you will say that it is minus of x2 plus 2x3 minus of 2x4 divided by 2, right? Divided by 2. This is x1. Since x2 you know, x3 you know, x4 you know, which are in S and T, that is fine. But I think I have calculated in the next page. So that is coming out to be, if you just do it, then that is coming out to be s plus t. Okay, that is coming out to be s plus t. So that is s plus t. So now I have x1, which is s plus t. Now I have x2, which is minus of 4 minus s minus 40, and then I can write the equation. I can write the whole vector because I have the x1, x2, x3, x4. So basically I can write the whole vector, which is x1, x2. Can you tell me how does the whole vector look like? It is basically x1 is s plus t, s2 is minus of s minus 40, and this is I think s3, x3 I assume to be s, and this is I assume to be t. So that's how I can calculate. Let me know if that is clear to everyone. See, from here they have asked the question, and that is why this is also very important to understand that how does everything is making any sense. So earlier what we did, earlier we started with this. See, earlier we started with this, and we want to solve this. Finally we got this as a solution, which was k into, earlier we got this as a solution, which was k into, x was k into 4 by 3 0 1, right? This was the solution that we got. Now here also we got the similar solution. I mean, looks like it is similar solution, but obviously the values are different. So here also we got the some solution, which is this, right? Okay, so let me do one thing. Let me write the earlier solution here, that I can just compare one by one. So I mean, there is no comparison because the whole set of equations were different. But anyway, let me just write side by side. So this kind of solutions we have got earlier, and now we have got this. So this is now, this is the earlier in the question one, in the question two, I can say. Let me know if both the questions are clear, and then I will clarify one very important thing. Okay, isn't it right? Check. Minus s minus 40. Which one? I think I did some mistake, right? Is this you are saying? 2 1 minus 2 minus 1. Oh, 2 1 minus 1 and 2. 2 1 minus 1. Okay, this is minus 1. No worries. This was minus 1. Anyway, let's not worry about it. Okay, and finally we are getting this answer. So basically this is the answer that we are getting. Let me know if you are fine. So earlier, let me just write the set of equations that we had earlier. Earlier we had this set of equations, and then we got that answer, where x3 was the free variable, because whatever is the free variable, I'm just making it k or s or t, or some values, right? So earlier this was the set of equations that we had. Now also we have we have some set of equations which are obviously different. Let me write those set of equations here only, because I just want to make you realize one very important thing, so that you get to understand this very clearly. So this is the solution that we are getting, and then I can say the set of equations where a is this. Now you notice one thing here. Here, if you notice that this is, let's suppose, x1, x2, x3, x4. Now I'm not writing the augmented. If you want, you can write the augmented also, which means a matrix. Okay. Now, if you just notice one thing here, the x3 and x4 were free variables. That's why I have made the x3 and x4 as s and t, right? Here this x3 was free variable only. That's why I have made this x3 as k. So let me write like this only. So it is basically, let me multiply by the k inside. It is k. It is k. So I made this x3 as k, and here I made this x3 and x4 as s and t, right? Because those were the two free variables. Now let me do one thing. Let me write this solution that I have gotten another question. Let me write this solution in some nicer way. I mean, that is looking nice, but let me write in more nice way. So basically you will say that this solution, whatever it is looking like, however it is looking like, this solution, you can write it same as s into something plus t into something. Okay, which means you will say that this solution, you can write it same as s into something plus t into something, the way you have written this, right? See, you have also written this in the same way. This was earlier, we have got this, which was 4 by 3k, 4 by 3k, 1 0 0 and k, right? This is what the solution that you have gotten, and then you are saying that you can write k into something, right? Which was 4 by 3 0 1. You can take k common. Similarly, I am saying that you can write this as s into something plus t into something. Do you want to help me? Can you write some numbers here? If it is s into something, then probably you can say that this will be 1 because you are taking this common, and then this should be 0. I think I will tell you the nicer way, but I think this will minus 1, this is plus 1. Similarly here, this is 1 minus 4 0 1. If you add them, you will be getting the same vector. See, s plus t, right? And then minus s minus 4t, then s, and then t, right? If you add these two, you will be getting same thing. So this is looking little nicer, right? Similarly, like I got this, but I'm writing k into something because it is looking little nicer to me. So whenever I got something, I'm just taking that common. So here, if I'm getting two free variables, obviously I cannot take s and t at the same time common. I'm taking differently, and I'm using some trick. So what is the trick that I'm playing to write it here? I'm basically, to get this vector, I'm just saying put s equal to 1, and every other free variable is 0, and every other free variable is 0. Every other free variable at 0. Here you put s equal to 1 here, which will be 1 1, and then t equal to 0, any free variable 0. So 1 plus 0, it will be 1. It is minus 1, it is 1 0, right? You put t equal to 1 here. If it is t into something, you put t equal to 1 here, and everything else is 0, right? Everything else is 0. You put s equal to 1 here, you put t equal to 1 in this, it will be 1 plus 0 minus 4 0, then this is 0, and then this is 1. So that's how, this is just a trick I'm telling you. Okay, this is just a trick. Basically, you can represent this as a linear combination of two vectors, something like this. Let me know if that is fine to everyone. Okay, now you notice one thing here is that these two vectors, okay, that you have got, see, this is s and t. Since you have put 1 here and then t as 0, so that's why these two vectors is basically 1 0 and 0 1. If you look only these two entries of these two vectors, then can you not say that these two vectors are linearly independent? Because you cannot get 1 from this 0. You multiply anything, right? You cannot get 1 from this 0. So that's why these two vectors, you will say, are linearly independent just by looking at these two entries. So whatever these two vectors you have got, you will say these are linearly independent, right? Okay, great. So let me know till now if everything is making sense, because now we are going to build something very interesting. Have you understood everything? We have just solved set of linear equation, and then we have said we have said, like, I mean, how to represent the set of linear equation into some parametric form. Now we will drive some intuition from here. Okay. So Utsav, is this clear to you? Anamika, is this clear? Piano melodies. That's a very nice name. Okay. There is a user called Piano Melodies. So nice. So is this clear? Akash, is this clear? Okay, great. Now you understood this. So let's just solve, or let's just ask one question, that how many solutions are here? You will say there are infinitely many solutions, because you put any value of the k, you will be getting infinitely many solutions, right? So this was the one thing that we have got. You will say, you put any value of k, you will be getting infinitely many solutions. For put any value of k, let me write in that, you get one solution. So that's why you will be saying that there are infinitely many solutions. There are infinitely many. Now you talk about this. Now similarly, you put any value of s and t, right? I mean, you put any value of s, you put any value of t, you will be getting some solution. Which means if you put s equal to 0, t equal to 0, you will be getting a solution which is 0, 0. I mean, which is 0 vector, which is fine. I mean, because ax equal to 0 has the 0 solution. I mean, you put any value of s and any value of t. You put s equal to 0, t equal to 0, you will be getting one solution which is 0, 0, 0, 0, 0, right? You put, let's suppose, you put s equal to 0, t equal to 1, you will be getting one solution which is 1 minus 4, 0, 1. If you put s equal to 2, t equal to 5, you will be getting one solution. So similarly, there are also infinitely many solutions, right? So if they ask you number of solutions, you will say infinitely many solutions. Why? Because if there is just one free variable, then there are infinitely many solutions. I mean, you do not need to worry about number of solutions. If there is a free variable, then there are always infinitely many solutions, right? Similarly here, if there is a free variable, there are infinitely many solutions. Now, let's ask a very nice question, which is that how many independent solutions are there? How many linearly independent solutions are there? And which was the GATE 2021 question? Okay. So now let's just ask that how many. There are infinitely many solutions that I know, which are actually looking like this, which will look like this: 4 by 3, 0, 1. Right? This is one of the solutions you get when k equal to 1. This is another solution which you get when k equal to 2. This is another solution you are going to get when k equal to 3, 12 by 3, 0, 3. Right? Like that, you will be getting a solutions for different values of k. Maybe for k equal to 0 also you will be getting some solution. K equal to 1, k equal to 2, k equal to 3, like that, right? You put any value of k, you will be getting a solution. So my question is that how many linearly independent and independent solutions are there? How many linearly independent? Let me know. This is just one, right? Any vector, any solution is just a multiplication of this, right? There is just one vector. There is just one vector that you have in your solutions. So there is just one solution, one linearly independent solution that you have, right? Only one linearly independent solution, because any vector is just a scalar multiplication of the vector that you are having. So only and only one linearly independent solution that you have. So it should be clear to everyone, because that has been asked in GATE also. In GATE 2021, they have just asked very simple question in another way, obviously in another way, right? So I will tell you that way. Maybe I have that question also with me. Maybe I'm having that question after 2-3 slides. Yeah, that is the question that they've asked. That they are saying that, see here, I don't know if you can see it or not. So I think you can see, right? So basically, just see it here. They are saying that P is a matrix such that the Px equal to 0. Every solution of Px equal to 0 is a form of this, which means इसके जितने भी solution है ना, वो ऐसे दिखते हैं, ऐसे दिखते हैं. 2, 5, 4, 3, 1. इसके multiple में है, इसके जितने भी solutions हैं. Then they ask the rank. I will tell you how to calculate the rank. Once you understand the concept, then finding the rank nullity, that is very easy. But is this question clear? कि they are saying कि every solution जो है वो ऐसा दिखता है. अगर if you want to solve for Px equal to 0, if you want to solve for Px equal to 0, it looks like this, right? Similarly here in our case also, if you want to solve for Ax equal to 0, that whatever set of equation you had, right? If you wanted to solve, then it looks like this, k into this, right? The same thing that we have here. Both are the same thing. Now let's just see that how to solve for the linearly independent solution. So if I just ask you how many linearly independent solutions, you will say 1. Let me know if that is clear, because every solution is a multiplication of this, right? Okay. Now similarly, let's just make it more interesting. Similarly, if I just ask you how many solutions are here, you will see infinitely many solutions. You put s and t anything, you will be getting infinitely many solutions. Okay, not a very good question, I will say. But if I just ask you how many linearly independent solutions are here, right? So instead of solutions, let me just ask you how many linearly independent solutions are here. Then can anyone tell me how many linearly independent? See, once you understand this, then only you will be able to understand a number of linearly independent eigenvectors that I will talk about later. Okay, eigenvectors में भी exact same लगता है. eigenvectors में भी तो a minus lambda I into x equal to 0 solve करना है, वहाँ पे भी तो ये x निकालना है, right? Then this x is just a solution, right? ax equal to 0 का solution है, फिर a minus lambda into x equal to 0 का solution. वहाँ पे इसी चीज को आइगन वेक्टर बोल देते हैं, यहाँ पे just a solution बोल रहे हैं. That's the only difference. So once you understand this, you will understanding the eigen vectors also. ठीक है? Because eigen vector में भी यही करना है, एग्जिट यही करना है. So if I just ask you how many linearly independent solutions are there, then what is your answer? See, every solution is just a linear combination of these two. And since these two are linearly independent, I'm sure these two are linearly independent because of just by looking at these two entries, I can say these two are linearly independent. So I will be saying that how many linearly independent solutions are there? I will be saying just two. How many total solutions? Infinitely many solutions. क्योंकि एक भी फ्री वेरिएबल है ना, तो सॉल्यूशंस तो इन्फिनिट है. Okay, if there is just one free variable, then there are infinitely many solutions. But if I just ask you how many linearly independent, then you will say that okay, let me ask a question which is basically if I just say that how many linearly independent solutions, then you will say that okay, tell me how many free variables are there, which means see earlier just one free variable you have, right? If there is one free variable, then you will be having this form, k into this form. If there are two free variables, then it will be basically s and t, then you will be having two vectors, something like this. Then number of linearly independent solutions are also 2. For example, let me just give you the example. Let's suppose there are three free variables. Okay, there are three free variables, which is basically looking like this: x1, x2, x3, x4. Let's suppose this is the vector where or maybe x5 also, and then this looks like this. Let's suppose these three are free variables and I'm just setting them to k1, k2, k3. Now these values could be anything, maybe k1 plus k2, maybe this is 2k1 minus k2, something. Let's suppose this is the solution that you have. How many solutions are here? You will say infinitely many. You put any value of k1, k2, k3 because these are free, you will be getting infinitely many solutions. Now if I ask you how many linearly independent, then you will say that okay, let me just represent. I mean, you do not need to do it every time, but for the sake of explanation, I'm doing it. So if I just ask you how many linearly independent, then you will say that okay, let me just represent this thing as a nicer form. So how you will be doing it? Just using a trick. What is the trick? For the coefficients of k1, just write I mean just put k1 equal to 1, everything else is 0. For the k2, write k2 equal to 1, everything is 0. Okay, for k3 do the same thing. So if you put k1 equal to 1, you will be getting 1, this is 2, this is 1, 0, 0. You put k2 equal to 1, you will be getting 1, minus 1, 0, 1, 0. k3 equal to 1, this is 0, 0, 0, 0, 1, right? So these are the three vectors I got, and then just by looking at last three entries, okay, just by looking at last three entries, I can say it is convenient entries like 0, 1, 0, 0, 0, 1, 1, 0, 0. I can say these three are linearly independent. Actually, these are always linearly independent. So if I just ask you how many linearly independent solutions are there, you will say any solution is a combination of these three vectors, right? So that's why three linearly independent solutions and total infinitely many solutions. If there are three free variables, three linearly independent solutions. If there are two free variables, two linearly independent solutions, just like this, right? Just like this, there are two linearly independent solutions. If there is just one free variable, then one linearly independent solution, right? So I hope you understood. Now just to summarize, what I'm saying here is that, see, okay, let me just summarize everything. What I'm saying here is this one. This is one solution. In one of the question we have got it, right? In another question we have got this solution where these two are the free variables, and let's suppose if there are three free variables, then I will be getting something else. So in one of the question, let's suppose I got this. Similarly, let's suppose if there are three free variables, then I will be getting something like. I mean, it depends on number of free variables, right? So if there are three free variables, I will be getting this. If there are two free variables, I will be getting this, right? So these are the different examples that we have seen. Okay. Now here, if I just ask you how many solutions are there, since this is just one free variable, you can put any value of k. There are infinitely solutions. In any of the case, there are infinitely solutions. But here it is one linearly independent because one free variable, and any solution is a linear combination of this. Any solution of linear combination of these two, that's why two linearly independent solutions. Any solution is a linear combination of these three, that's why three linearly independent solutions, right? So if they ask you number of linearly independent solutions, then it becomes more tricky. I hope you understood. So finally, I can say that number of linearly independent solutions, linearly independent solutions is actually equal to number of free variables. A number of free variables are actually also called something nullity that I will talk about later. Don't worry. I mean, there are called number of see the total variables that you have, total columns or the total variables. Total variables. I mean, let me write the columns because you have to be very specific. These are the columns. For every variable there is a column, right? Okay. So the total variables that you have is basically n. Let's suppose. Then out of them, some are pivot variable, some are free variable. Let's suppose pivot variable are let's suppose k, then free variable will be n minus k basically, right? So it is called rank, pivot variable is called rank, and free variables are actually called nullity. It is just one definition, and there is actually other definition of nullity, which is the dimension of null space, but you do not need to worry about it. Okay. So number of free variables are also called nullity, and the total, since this is just a total n variables that I have divided, so rank plus nullity is n. Rank plus nullity is n. What is rank? Number of pivot variables. This is number of free variables, and total variables are n. That's why rank plus nullity is n. Okay. So I hope that is okay to everyone. That is called rank nullity theorem. Now, if I'm saying number of linearly independent solutions, that is basically depending on how many free variables you have. If you have 2 free variables, your equation will look like this, right? If you have 3 free variables, your equation will look like this. If you have 1 free variable, your equation will look like this. So basically, number of free variables are determining how many number of linearly independent solutions are there. Is this clear to everyone? Now I will ask one more. I will ask one more thing, and I will relate all of the things all together. First, let me know if that is fine to everyone or there is any doubt. Okay. So Mohi Bodhin is asking that what is the linearly independency of the solution which is having no free variable. If there is no free variable, then there is just a unique solution, right? There is just a unique solution. In that case, I say that I do not say linear dependency independency, because if there is just one vector, then the one for the one vector, it is not defined that it is linearly dependent independent. The linear dependency and independency is defined for the set of vectors. So if there is just one vector, if there is just a unique solution, okay, if there is just a unique solution where the rank, this is full rank, then I do not say it is linearly dependent or independent. Okay, I hope that is clear to everyone. Cool. Now let's just do one thing. Let's suppose I have a matrix. I reduce it to equivalent form, and I got, let's suppose, this column. Let's suppose this column, this column, this column. Let's suppose these are the two columns that I have here, which are basically the pivot columns. Pivot, and this column is, let's suppose this column is my free column. See, I define pivot and free column for the matrix A, not for the augmented, because for the augmented, this is not a variable. Okay, I mean, if you want, you can write the zeros here, but for the zeros, you do not say it is a free or pivot, nothing. Okay, because it is not even a variable. The XYZ variables are here. This is RHS. This is RHS. For this, you do not say it is pivot or free. So don't, if I'm saying the pivot or free, then I'm talking about the LHS variables, not about the RHS. Never about the RHS. Okay. Now let me ask you one interesting thing. Let's suppose that this is the matrix that you are getting. So after the solution, number of linearly independent solutions is equal to how much? Tell me fast. Number of linearly independent solutions will be 1, right? Now let me ask you number of linearly independent vectors in A. Then number of linearly independent vectors in A. Then what is your answer? See, if I'm asking number of linearly independent solutions Yeah, actually it is little confusing to be honest. I mean, like as a student you might get confused. The number of linearly independent solutions, it depends on the free variable, because that's how you represent, right? I mean, that's how you represent 1 1 3 1 k, I mean 1 0 1 whatever, right? And then k, if there's one free variable, then k into something. If there are two free variables, then you will be representing something like this. If there are three free variables, then you will be representing into k3, something like this. So it depends on number of free variables and how you're representing the solution. So your solution depends on number of free variables, right? I mean, number of linearly independent solution depend on number of free variables. So which is one? But if I just ask you number of linearly independent vectors in A, that will be two, which will be basically pivot columns, which is basically the free columns. Now, whenever I take this class, if I do not make this clear, then student get confused. Students say that, okay, sir, you previously you told the number of linearly independent vectors are pivot columns. Now you are saying number of linearly independent solution is free columns. Sir, what is this? See, here I am saying solutions. Here I am saying columns, or the vectors, right? Number of linearly independent columns, like columns in A, right? Columns in A, which is 2. This is the pivot columns, which if I just ask you about the A, then it is the pivot columns. If I ask you about the solution of X equal to 0, it is the free columns. So that's where you need to be very careful. Okay. And the total summation happens to be N. Isn't it very interesting? The total summation happens to be N, right? Cool. So if you have understood this, then let's just solve some question. Suppose I say that there is a system. This is a question, okay? There is a system Ax equal to 0 that has solutions of form A1, something like this, okay? I mean, that is, I mean, I'm not writing it, but anyway, uh, you can write something, right? Minus 2, minus 2, anything. You can write minus 2, uh, 3 1 0 5 9 0 1, anything. I mean, these two last should be 0 1 and 1 0. That's all. So suppose that you say that this is the case where your solutions are of this form, right? Oh, so here a dimension is, let's suppose, and anything 10 into 4. A dimension is, now I'm saying a is a dimension of 10 into 4. Then I'm asking you a couple of things, which is basically I'm saying the solution of this form. Now let me ask you for a couple of things. First is that, what is the rank of A? What are the number of linearly independent solutions in Ax equal to 0? Number of linearly independent solutions in Ax equal to 0. Let me know both of the things. What is the rank of A? What are the number of linearly independent solutions? See, here the number of free variables are 2. So that's why number of linearly independent, you can say that every solution is a combination of these two vectors. So it is 2, right? And then you will say rank of A. Rank of A is number of pivot columns. Free columns are 2. Total columns are 4. So that's why it is also 2. Isn't it? Both are 2. Yes, yes. That is clear to everyone. So it should be clear that how we are doing these kind of questions. Now, once you understand this, that okay, see, the key idea is to just understand this picture. The key idea is that number of free variables is basically determining that how you write the solution, right? If there are 3 free variables, you will be writing the solution something like this. If there are 2 free variables, you write the solution something like this, right? So it is just a way of writing the solution. If you have 2 free variables, you will be writing like this. If there are 3 free variables, you will be writing like this, right? You will be writing like this. If there are 1 free variable, you will be writing like this. If there is no free variable, then you will be writing just like this, 1 2 3. I mean, you will not be having the parametric form. This is a unique solution, right? This is a unique solution. So now, once you understand that number of free variables are actually determining number of linearly independent solutions and number of pivot columns are actually determining the rank, then you can do these kind of questions very easily. Now let's just go to the question which I was waiting for, which is GATE 2020. So let's just see this question, what they're asking, and let me know what is the answer that you're getting. See, once you know the concept, then solving these kind of questions is very, very easy. If you do not know the concept, then it is actually, I mean, it takes a lot of time. And after that also, you will not even be able to understand the solution. Okay. Someone give you the solution. Let me know what is the answer you are getting here. Yes, yes. So everyone is saying 4. I'm quite happy to see that everyone is saying 4. So that's great. So all of you are saying 4. That's really amazing, right? So everyone has given the correct reasoning, and the answer is in fact 4. And that has been a very easy question. If that I don't know the marks, I think they might have asked this for the two marks. And see how easy it is, right? Everyone is saying 4. That's really nice to see. How it is for the 2 marks if you know the correct concept. Getting 2 marks here is extremely easy. I don't think it will even take more than 10 seconds just to get 2 marks. Right? If you know the correct concept in linear algebra, then for these kind of tricky questions, you don't need to do anything. You just apply your intuition. Okay. Now, if this is clear, then let's solve few more questions. Okay. So let me know if everything is clear, and then if this is clear, then why not solve few more questions? So what they're saying, consider matrix which is of 8 cross n. Suppose a system Ax equal to 0 has some non-trivial solution such that the solutions are linear combinations of 3 linearly independent vectors. What can you say about number of linearly dependent columns, number of linearly independent columns? Tell me. If solution are basically combination of 3 linearly independent columns. Very easy, right? See here, they are saying 3 linear independent columns. That means free variables, which means dependent columns are 3. Independent, which means pivot variables, are 6, right? Because total are 9 columns. Yeah, great. So everyone can answer this very easily. This is 3 and 6. Now maybe I have couple of more questions. Yeah, let's just solve this question. What they're saying, I hope you can see this question, right? Okay. What they're saying, let A be a M cross N coefficient matrix. Coefficient means that I am not augmented. So there is two definition actually. Augmented. I mean, they will make it clear. Don't worry. They will not trick you in the definition. Augmented matrix means you are actually augmenting. Coefficient matrix is you are not augmented. Not augmented. Just A. Basically, just A. Okay. Not A and then augmented matrix. Cool. So what they're saying, you have A, which is basically corresponding to homogeneous system of equations, and suppose A has the rank R, then the solution to the corresponding system has n minus r parameters. Parameters means that these are the parameters. These are the two parameters that I have. I will say these are the two parameters I have. Right. So tell me, do you have n minus r parameters there? Is this true or this is false? True, right? This is easy question, which is true. So you can solve this question. This is quite easy question, which is basically true. Okay, cool. Now, let's solve this question. Okay. Um, maybe before that, I can just tell you something about the non-homogeneous, and then I will be solving the questions mix of the questions. Okay, of the non-homogeneous and homogeneous. So before that, let me just ask you in a summary whether these kind of questions are clear to everyone. These kind of questions. I mean, they say that okay, solutions are representing like this the number of free variables and the pivot variables. I mean, I hope that's very clear, right? Okay. Now let's see non-homogeneous system. Let's see non-homogeneous system. In non-homogeneous also, the things are very easy. You will be putting A and then you will be putting B here. You apply the same thing. Then I say that, see, the homogeneous system is always having the trivial solution. I say the non-homogeneous system may or may not have the solution. So what will I say? That I will observe that in the non-homogeneous system, do I have any row here, right, in the row reduced form, which is basically saying that these are all zeros, but finally you get some non-zero here. Suppose you have some row here, row something like this, which means these are zeros and this is non-zero. Then you will say that you are going to have corresponding to this, you are going to have 0 equal to non-zero, right? 0 equal to non-zero, which means this will not be having any solution. So basically a non-homogeneous set of equation does not have any solution only when you have zeros and non-zero, something like this, right? Otherwise it always have the solution. See, if you have zeros and this is non-zero, then you do not have the solution. Otherwise you always have the solution. So let me probably go to the slide which tells this. Yeah. So a non-homogeneous system may or may not have a solution in case if the situation arises where the solution, where your matrix has zeros and non-zero, then the solution will not exist. Otherwise, solution always exists, right? Otherwise, you always have solution. Now again the same story. Do you have the free variable here also, or you do not have the free variable? If you have the free variable, right? I mean, if this is zero, I mean, if this is so basically you are having something like this where you have these are zeros, then this should also be zero. Then only you can talk over the solution, right? So now again, if there is a free variable here, if there is a free variable, then infinity solution. If there is no free variable, then unique solution. Okay. Let me know if that is clear to everyone. Thank you so much. So Saloni is saying that I'm watching the second marathon and came here to thank you. CN marathon she is watching. That I must say that no can bring no can be bored. Okay, no can be bored by your teaching, and the upcoming she is looking for the upcoming marathons. Thank you so much, Saloni. So it is better if you can just put a comment there also. I mean, it will just help other aspirant and just us also. Yes, homogeneous means RHS is all zeros. Okay. Now, maybe let's just solve some of the questions using for the homogeneous and non-homogeneous. But before that, I just want to give you one more clarity about the non-homogeneous, which might not be so much important at this point in time, but still, let me just. Just a sec. I'm bringing that slide which I'm. Yeah. So let's just see that how to solve non-homogeneous equations, right? It is also very easy. You know how to solve homogeneous equations. Let me just remind you that if you have this and if you want to solve non-homogeneous, which is ax equal to 0, then how you do it? You basically convert that to equivalent form that we did, and then we find out the free variables. Then you basically finally come up with the answer, right? Which is something like this. So basically you can do it, right? Very easily. How? Solve it. Then what are the free variables? You just set them and then you calculate for that. That's how you solve ax equal to 0, right? Now let's just solve ax equal to b. So earlier this b was 0. I have the same example actually, but now let's just solve the non-homogeneous equation. So where this b is now non-zero. Now what you need to do? Again, very easy. You just augment it, something like this, right? This is then you convert that to a equivalent form. Let's suppose this is the equivalent form you are getting. What are the free variables? X3 and X4 are the free variables. You just set X3 and X4 as S and T and then solve it, right? See, there is no zeros and non-zero, so solution exists, solution definitely exists. Then you for the free variables you just set them and then you solve it. So basically if you solve it, then you will be getting something like this. Let's suppose if you solve for S and T, you will be getting something. I hope it is fine to everyone. I mean, that's not very much required, but I'm quickly telling you. That's why I'm quickly telling you. So to solve it, you also set S. I mean, free variables as S and T, and then you just find out the x1, x2. Very easy, right? Now again, if you try to represent that just like in nicer form, so you take this vector separate first, and then this vector, the way you have represented earlier, you can represent like this. So earlier you were just getting this answer, but now you are getting something plus, right? So something plus. Earlier you were just getting this answer. So basically, whatever the solutions, whatever solution earlier you get, you are getting just some additional vector extra, right? In ax equal to b. That's the only difference. So if ax equal to 0 has some solution, I mean in geometrically, if this is a plane, then ax equal to b is a plane that is some intercept away. That is basically having, that is saying that, okay, I'm some intercept away from you. That is just a non-homogeneous. Okay. So that's the only difference between homogeneous and non-homogeneous. Cool. Now, now let's solve some questions related to rank and all. Like related to rank and rank of A and rank of B. So let me first know if the solution is clear for the non-homogeneous. I mean, is this slide is clear? So whatever you have earlier, you are going to have the same thing, but you are just going to add something. And then we will be solving some more questions related to rank and all, so that this thing get crystal clear, and then we will be moving to eigenvalues and eigenvalues. Okay. So let's just continue then. I hope you understood this. Then let's just continue. Cool. So basically, I was saying, I was saying that a non-homogeneous system does not have solution if and only if zero and non-zero. So this is actually true, right? Now let's just understand this using the rank formulation. So basically, what I will say, that that if rank of A and rank of AB, which means rank of A looks like this. This is your A, and then you will be augmenting. Let's suppose your augmented look like this, right? So now what you need to do, this is basically, let me just first tell you very nicely. This is the matrix that you have, where this is A. Now you convert that to a row echelon form, where you will be having some free some pivot variables. Let's suppose these are the two pivot variables. These are the free variables, right? And then you might be having, since it is the echelon form, then you might be having some zeros. So if this is zero row, you will be having this at the end. Sorry, there will be just one zero, because this is just one vector. Okay, if there is a zero row, you will be having at the end. If there is a there are pivot, then you will be having, let's suppose, some pivot columns. These are the two pivot columns, and then you will be having some free columns and all, right? Now suppose I say that this is A and this is B. So whatever A you have, you are just having some B in that, right? So let's just ignore this. Let's just ignore this. Then what I'm going to say here, basically, let's just ignore the zero rows. So if this is A, if let's suppose here this is A, if you append B, this is A, let's suppose, and if you append B, then tell me what is the rank of A, and what is the relation between rank of A and rank of A. So basically, you append B, let's suppose this, right? So now you will say that whatever rank it is, right? I mean, you may be having zero, non-zero, whatever rank it is. Now, if you are adding B, okay, could be non-zero. Let's suppose these are the non-zeros, so it is B. These are the non-zeros. Now, the rank of AB, the rank of complete matrix, will definitely be either equal or greater than rank of A, right? Rank of AB is greater than or equal to rank of A. Why? Because you are adding one more column. If you are adding one more column, whatever the number of linearly independent columns earlier, whatever it was, right? Then you have one more column, which either you will add to one. So basically, in fact, it is basically either plus one or just equal. Either you are adding one more linearly independent column, or you are just saying that you are not contributing anything, right? That's the only thing that you are doing. Now, in terms of rows, you can say that if this is having, let's suppose, this row is having pivot, this row is having pivot, this row is having pivot, but earlier, let's suppose this was the zeros, right? Earlier it was the zeros. Now, in terms of rows, you can say that if you are adding B, then if you add non-zero here, then basically what you are saying, that you add non-zero here, then the rank will get increased, right? If you're adding non-zero here, then the rank will get increased in terms of rows. Is this clear to everyone? So earlier, whatever the rank you have, now if you are increasing the rank, then it must mean, see, if you are increasing the rank, whatever A you have, A will look like this. This is this. Maybe earlier you have all zeros here, right? All zeros. Maybe you have more columns, no, less columns, does not matter. So let's suppose you have, this is your A. In terms of row, I'm telling. Now if you add some vector B, You add some vector b, and now it depends whether this is 0 or non-zero, right? If this is 0, then rank of a and rank of b are equal. Rank of ab are equal. If this is non-zero, then rank of ab is greater, right? So basically, if it's 0 and non-zero, it all matters, that whatever you are adding. Now this final vector, right? The final entry is 0 or non-zero. Cool. Now basically, what you need to do, you if someone asks you that whether someone says that that if this rank is greater, then you immediately must infer that this is the case of 0 0 0 and then non-zero. This is the case of 0 0 0 non-zero. It means solution does not exist. If someone says these both rank are equal, then you must infer that this is the case of 0. That's the only interpretation. I mean, that's how you should be linking this rank thing and 0 0 0 non-zero. So see, this 0 0 0 non-zero should be clear to everyone that if this exists, then no solution, right? Now, instead of saying 0 0 0 non-zero, they will say rank of A, rank of AB. Then you must relate rank of A and rank of AB with the 0 0 0 and non-zero concept, right? If this is equal, then this must be 0. If this is greater, either it is equal or greater. If this is greater, then this must be non-zero, right? Okay, now tell me if both are not equal. Not equal means this must be greater, which means what is the case? 0 0 0 non-zero, right? This is the case. It must mean that there is a no solution. Then what is the answer here? Let me know quickly. What is the answer that you are getting? A, right? No solution. Now let's move to more questions. Suppose if both are equal, then it means what? It means that 0 0 0 non-zero does not exist. Non-zero does not, right? Now it will depend on the free variable. So it does not exist. Now maybe there is a free variable, may not be free variable. Basically, you might be having here pivot, and let's suppose there are multiple columns. Like for the pivot, you should be looking at the columns actually. This is the column. This column has the pivot. This column has the pivot. But all other columns, let's suppose, does not have the pivot. I mean, all are zeros. Everything is zero. There are many rules. So this is having pivot, this is having pivot, and all other columns are not having pivot. So this is pivot column, but this is not a pivot column, this is not a pivot column, this is B, right? Definitely it is B. Since they are saying rank are equal, so that's why 0 0 0 non-zero cannot exist. If it is all zero, then it is zero also, right? So basically it depends on the free variable. If they are asking you that what is the solution, then you will say there is definitely a solution because 0 0 0 non-zero does not exist. But the solution is unique or infinite, you don't know. It depends on the free variable. Maybe unique, maybe infinite, right? So that's why these two are correct. Yes, that is right. Okay, so that's the interpretation I wanted to make clear, that if they say in terms of rank, then what you should infer. If they say 0 0 0 non-zero, then what you should infer. So basically they will never say 0 0 0 non-zero 0 0 0 0. That's up to you, that you should be interpreting, and that's very easy. If rank are equal, then 0 0 0 non-zero does not exist. If rank are not equal, then it exists. That's the only interpretation. So basically you can have this flow chart where I will say that system linear equation Ax equal to B. It is about the non-homogeneous. If this is exist, no solution. If does not exist, then you will be asking whether this is a free variable or not, right? Free variable, yes. Infinite solution, no. Unique solution. Similarly, you can say the same thing, exact same thing in terms of rank also. See the exact same thing I have said in terms of rank. If not equal, it means that 0 0 0 non-zero exists. I mean, these are the two slides I'm quickly just flipping. Okay, so see, both are one-to-one mapping. This is 0 0 0 non-zero exists, so it means that inconsistent. If rank are equal means it does not exist, then you will be asking the free variable. Free variable does mean that what is the rank of A. If it is equal to n, no free variable. If less than n, then it is infinite solution, because there is a free variable, right? It means there is a free variable. So these two flow charts are actually same. You just need to understand. You just need to make a mapping of it. Okay, cool. See here, it means no free variable. It means there is a free variable. All of this we have taught in the Go classes course. So I have taken these screenshots from there, because I do not need to write again and again, since it is marathon. Okay, we have seen how to solve it. I think we are almost done. Let's just solve 2 3 more questions and let's just wrap up this session. Then we will be starting one more session for eigenvalues, eigenvector. That's the last topic that we need to do for our gate purpose. And then this is actually extremely interesting, extremely nice topic. I will say that is very nice, elegant topic that if you attend that lecture, you will be very happy by seeing that what is eigenvalues, eigenvectors, what it is actually doing, why they are in limelights. I mean, why they are so popular. First of all, what what they are doing such that they are so popular. Anyway, let's suppose A is having a size m cross n. Then if this is the case, then which of the following is true about the solutions of Ax equal to B? If if m and n or both are equal, then rank is n. If rank is n, then it means every column is having a pivot, right? Every column is having a pivot. This is a pivot, this is a pivot, this is a pivot. Every row is having pivot. And B, whatever B you have, it will be looking like this. And you will say that since every row or every column is having a pivot, then I think this is a unique solution, right? There should not be any confusion. There is exactly one solution. Is this clear to everyone? Because every row and every column is having pivot, there is no zero rows or something. So you can easily solve it. So this B will not be having any extra because the dimension of B same as the dimension of this columns of A. So B will be just having something. So this is unique solution. Very easy question, right? Okay. So I think what is the answer here? B. Cool. Let's just solve this. Consider matrix A, m cross n size. If the rank of A is n, then which of the following is true about the solutions of X equal to B? A cross m size. They are saying the rank of A is n, which means every column has a pivot. Every column has a pivot. So this is the column. This is the column. Okay. These 3 columns, let's suppose, have the pivot. Uh, every row need not to have the pivot. So you can have the 0 rows, right? You can have 0 rows, which is something like this. I mean, you can have many 0 rows basically, right? I mean, you do not have something like this because then this column will not be having a pivot. So below this last pivot, you can have many zeros. So situation is something like this, right? Now, what they are saying that what the true about the solution of X equal to B may exist, right? You do not know. You, it depends on the B. So whatever B you are bringing, will be something like this. Will be as good as long as this columns of A, vector of A. So it depends on this, right? Maybe zero, may not be zero. So it depends on B. If let's have 2 cases. If this is non-zero, then there is no solution. So you will say there is either no solution. It depends on B actually, right? Are you getting me? If this is zero, then if this is zero, then it means do you have the free variable? Tell me here. Do you have the free variable here? Let me know if you have the free variable. If this is zero, then there is a solution definitely, but infinity solution or not, it depends on the free variable. Do you have the free variable? I think no, right? You do not have the free variable because every column is a pivot. Don't look at the row, okay? See, don't do these mistakes. Don't look at the row. Always look at the column for the free variable and the pivot variable. You do not have the free variable because free variable x3 equal to k or something, right? So you talk about this x1, x2, x3 whether they are free or not. So that's why you will say that there are no free variable. That's why unique solution. So either they are unique solution or there are okay, there is a unique solution, exactly one solution, or there is no solution, right? Zero or one solution, yeah. So C is the answer, right? So C is the answer. Either there is zero solution or one solution. Let's do more questions so that you are more comfortable with these kind of things. Suppose if rank of A is m, then what does this mean? Every row has a pivot. Okay, this is one row which is having one pivot. This is another row which is having pivot, right? And every row is having actually a pivot. Now, now since there is no zero rows, now tell me, can you have the free variables here? I think you can definitely have the free variables, right? Let's suppose this column may not be having a pivot. This column may not be having. Yeah, you can append the zeros, so you can have the free variable. Okay. So since every row is having a pivot, there cannot be zero rows, right? In the A there cannot be zero rows. So 0 0 0 non-zero. In the B you cannot bring the non-zero because there is no zero here. So the solution always exists because 0 0 0 non-zero cannot be the case. You're getting my point? See, every row has a pivot means there is no zero rows. So 0 0 0 is not even the case. So let's not talk about it is non-zero or not, right? So you will say that there is always a solution if every row has a pivot. If it means every row has a pivot, there is always a solution. Will there be an infinite solution or finite solution? It depends on the free variable, right? There can also be a free variable. So either it is a infinite solution or a unique solution. So I think infinite solutions or the unique solutions, right? See, yeah, I think I'm right, right? Can there be no solution? Okay, so what do you think? Let me know. I suppose that it should be infinite, or let me just see the answer there. There are infinite solutions. Okay. Why there is no Oh, sorry. There is one condition that I missed here. M is not equal to n. M is not equal to n. Okay. There is one condition that I missed here. So assume this condition, right? Now let's just answer this question. So 0, 0, 0, non-zero cannot exist. Now just tell me, can the extra zeros exist? See, extra columns also cannot exist. If there are three rows and three columns only, sorry, extra column has to exist. Extra column has to exist because m is not equal to n, so at least one extra column will be there. So that's why there are infinitely many solutions. Yeah, it was a nice question, right? The m not equal to n means there is at least one extra column, because if there are three rows, then not just three columns, there is one extra column because m is not equal to n. So there has to be one extra column. That's why A is the answer, which is infinitely many solutions. Okay, cool. I hope you understood. That's the answer. Actually, these are the easy questions, so that's why I mean, easy and interesting actually. I'm sure that without proper understanding, you won't be able to do it. Now, what they are saying, if rank of A is less than M and N, which means they are saying that you have, let's suppose, three rows and three columns. So there are zero rows because not every row is having a pivot. And since rank of A is less than n, there are definitely a zero column because not every column is having a pivot. So your A is looking like this. I mean, there are definitely zero rows and zero columns, right? If this is less than m, which means not every row is having pivot, not every column is having a pivot. So it is something like this. And now you bring B. Now if you bring B, you might bring non-zero here, right? You might bring non-zero here. So it means that solution could be no solution. And suppose you are bringing B, which is actually zeros, then there is always an infinite solution, right? There is always infinite, either no solution or infinite solution. So I think D is the correct. Okay, that is also a nice question. All of these questions are formulated by me, which means like I just thought through it that what should I put here. So all of these questions you will not find it anywhere. All of these variations I just formulated for the sake of explanation, and I hope you are liking those variations. It take a lot of thinking just to come up with the idea that what to do. So D is the correct answer here. Now, there are two questions, which is GATE 1996 question, and this is GATE 2016 question. So there are two questions which are nice question. Let's just do one thing. Let's just spend some time in that. Okay, I just ask you to spend some time in that, and then I will be solving these two questions in the next lecture. So just comment out whatever your thought process it is, right? Just comment out, just let me know that what you thought about this question, let me know that how your thought process is going on while you are watching the lecture, how you are coming up with the solution. Just let me know, just try it yourself, so that it is better practice to you, and now you will be solving these great questions, right? These are not straightforward questions, but once you understand these things and how I am solving the question, whenever someone is saying rank is less than m, I'm immediately saying that okay, not every row is having pivot. Whenever someone is saying rank of A is less than n, I'm immediately saying that okay, not every column is having a pivot. So that's how I'm solving these questions. So similarly, I'm just asking you to solve these two questions, and then we will be just solving these two questions in the next lecture. So let me know if there is any doubt. We have covered it very nicely, and we have solved many of the questions. We have basically covered in such a way that you have the proper understanding of linear algebra. Now there is just one topic remaining, which is eigenvalues and eigenvector. We will be just covering that topic also, so that your whole linear algebra can be covered. Okay, Alman is saying the second question we have done yesterday. um yeah, second question we have done yesterday, so you can just do this question. This is a nice question. Just let me know what you think about this question. So thank you everyone. Take care. Bye bye. I will just schedule a next class. I will just let you know that when we are conducting a next class. Maybe today, maybe around 8 p.m. I will be scheduling 8 p.m. to 10 p.m. I will just let you know. Okay. Thank you. Take care. Bye bye. Just a small request as always. Just put a comment if you are liking the session. Just put a comment here that you have really understood everything. Okay. And if there is any doubt, just let me know. If there is any feedback, just let me know. If you are really liking the sessions, just please let me know. Mohandin is saying that is there any relation between null space and nullity? Yeah, actually, you need to understand what is a space. Basically, like I mean, yeah, there is obviously a relation. Dimension of null space is called nullity. That's how nullity is defined. But you first need to understand what is the dimension of the space, not a vector. The dimension of vector is very easy. By looking at the coordinates, you can say, okay, these are having two coordinates. It is in R2. These are having three coordinates. It is in R3. But dimension of space is something different. Okay, which is basically called the number of basis vectors. So you need to understand that if you that's not required for gate, but if you really want, we will be covering that for the IIT and ISC interviews later. There are just a space topic that we have left it because that's not required for gate, so we can definitely cover it after gate. So just comment it out if there is anything that you think that you have understood from these lectures. If there's something that you think